Nagaa jirtu akkam kabajamtootaa fi jaallatamtootni maatii qubee akkaadaamii akkam nagaa keessanii fayyaa keessanii galata waaqayyoo haa ta'u an nagaa kiyyaa akkuma beekamu an barsiisaa keessan gammachuun jedhama. Yeroo darbee barnoota fiiziksii kutaa 12ffaa sirna barnoota haaraa wajjiniin eegaluun keenya ni yaadatama. Kanaaf yeroo darbe egaa boqonnaa lammaffaa paartii tokkoffaa wajjiniin ilaallee turre isaanis sochii daayimeenshinii lamaa yookaan immoo sochii kallattii lamarra taasifamu erga wajjiniin ilaallee booda viidiyoo keenya darbe paartii tokkoffaa irratti piroojeektaayil mooshinii ilaallee turre. Piroojeektaayil mooshinii maal akka ta'e ilaalleerra. Kana malees piroojeektaayil mooshinii kana iddoo gurguddoo sadiitti qoodnee ilaalleerra. Horizontaal piroojeekshin, vertikaal piroojeekshinii fi inclined projection jennee ilaallee turre jechuudha yeroo darbe. Kanaaf isaan kun equation isaanii maal akka ta'e tokkoon equation isaanii maal akka ta'ee fi akkasumas fakkeenyaatiin kan deeggarame keessattuu termoota horizontal projection keessatti fayyadan eenyufaati, vertical projection keessattuu inclined projection kan jedhu keessatti walumaa galatti waliin ilaallee turre jechuudha. Barnoota keenya guyyaa har'aa viidiyoo keenya paartii boqonnaa lammaffaa paartii lammaffaa irratti immoo rotational motion kan jedhu wajjiniin ilaalla jechuudha. Rotational motionii sochii daayimeenshinii lamee keessattidha kan nuti ilaallu. Rotational motionii kanas rotational motionii maalidha? Akaakuuwwan rotational motionii akkamiin baruu dandeenya yookaan immoo rotational kinematiksii fi rotational dynamiksiin garaagarummaan isaanii maali? Jennee wajjiniin ilaalla jechuudha. Rotational motion kan jennu rotational motion is a motion of a body in which all of it is particle move in circular motion. That means the motion of the body in which all of it is particle move in circular motion with common angular velocity about fixed axis. This means what? Sochiin tokko bifa serkilii qabatee kan deemu yoo ta'e, yommuu ta'u, innis angular velocity wal fakkaataatiin aksisii tokkorra kan deemu yoo ta'e, sochiin sun rotational motion jennee waamna jechuudha. Kanaaf example rotational motionii kana yookaan immoo fakkeenyonni sochiilee rotation jennee waamnu kana maalidha? Jireenya guyyaa keessatti gargaarra. Isaan kun fakkeenyaaf rotation of earth about its axis. Sochii lafti aksisii yookaan siiqqee mataa isheerra ittiin naannoftu rotational motion jennee waamna. The rotation of flywheel swing machines, rotation of ceiling fans, rotation of wheels of a car. Isaan kun hundi isaanii sochii angular velocity wal fakkaataatiin siiqqee mataa isaaniirra yookaan fixed axis jedhu siiqqee dhaabbataa mataa isaaniirra ittiin socho'an jechuudha. As keessatti rotation of an object of fixed point can be in two direction, which is clockwise or anti-clockwise. Kun beekamaadha. Sochiin geengoorra yookaan immoo sochiin serkilii ta'e tokkorra taasifamu yookaan anti-clockwise ta'a gara kanaatti ta'a yookaan immoo clockwise ta'a gara kanaatti ta'a jechuudha. Beekamaadha jechuudha. Yookaan asii ka'ee kallattii kanarra asiin deema yookaan immoo kallattii kanarra akka kanaa deemuu danda'a jechuudha. Kanaaf directioniin into directionidha yookaan clockwise ta'a yookaan immoo anti-clockwise ta'a jechuudha. So what are the term which is used in rotation? Sochii rotational motion jennu keessatti termoonni nuyi fayyadamnu maalidha? Before we going to study the term of rotational motion, let we see the following example. Example is CD is rotating about fixed axis through or perpendicular to the plane of the figure. Here, look at this one. A CD is rotating perpendicular to the plane of the figure. Here, when a CD is rotating in this motion according to O, there is an angle theta, which is there is a radius, two radiuses, which is R, and this is the starting point of the motion when the motion move into anti-clockwise direction. Here it's reference line. Reference line. Here this is a radius. In this case, we can define any terms from this figure. First, angular displacement. Angular displacement means this is what? An angle which makes from the given radius, the terminal point and the initial point. Here, this is the initial point. Here, this is the terminal point. The distance or the angle between initial point and terminal point is what? Angular displacement. So, angular displacement refers to the measure of the amount of and direction of the object around particular axis, the measure of degree or radians. The measure of degree or radians, which is what? Which shows the amount or the direction of the object around particular axis. So it is measured by degree or radians. Degree or radians. So this is angular displacement, is one of the terms which is used in rotational motion. For example, as a particle moves along a circle from reference line, which is at an angle 0, that means the starting or the initial point of the motion, it moves through an arc of length s. An arc of length s. This means what? When it starts from this initial lines to anti-clockwise direction, here this is the radius, here this is the radius, we have what? We have angular displacement here. Then the motion moves arc of length s. This is arc of a circle. Here this is a circle. The motion is can be occurred in this circle. This point is arc of circle. This arc is represented by s. Then the arc length is related to the angle through the relationship by arc length. Arc length becomes radius of the circle times angular displacement or the angle formed between initial and terminal sides. Initial sides and terminal sides. So this is what arc length. Whose arc length is can be represented as tangential displacement. Gara fuulduratti ilaalla jechuudha. Inni kun immoo maal akka jedhamu. Fakkeenyaaf a particle P rotating on a disc moves from A to B along the arc of circle in the following figure. For example, asirraa ka'ee hamma asitti from T initial to T final deema jechuudha. Yeroo inni itti asii ka'e T initial yeroo inni itti as ga'e T final yoo jenne jalqaba gaafa ka'u teettaa 0 qabna yookaan immoo initial displacement qabna. Gaafa bakka kana ga'u yeroo addana kanaa jalqabu teettaa 0 qabna jechuudha. From related to this initial and horizontal. Measuring the initial and horizontal the angle between initial and horizontal, we represent theta 0 or initial displacement. After that, when the motion is go from A to B at T final, we have an angle start from the horizontal. When we measure distance from the horizontal, we got what? Theta final or final displacement. Having this concept in your mind, then this quantity change in displacement is defined as the angular displacement of rigged objects. That means what? Change in displacement means the difference between final displacement and initial displacement. This is what? Change in displacement or change in angular displacement. So a radian is a convenient measure of an angular displacement because it naturally expresses angle in terms of pi. This means what? We have usually we measure angular displacement by using radians. Yeroo baay'ee angular displacement kana raadiyaanii fayyadamneeti jechuudha kan nuti safaru. Kanaafuu raadiyaaniin kun immoo one complete turn of a circle yookaan immoo degree 360 faana hariiroo akkamii qaba? One complete turn of a circle means one revolution jechuudha. So one revolution is equals to 2 pi radians is equals to degree 360 full circle tokko jechuudha. Full circle tokko 2 pi radianidha. Half circle pi radianidha jechuudha. Kanaafuu inni immoo one complete revolution jennee waamna. Kan kun angular displacement and linear displacement are the two terms which is used in rotational motion. The next one is angular velocity. Angular velocity is what? The rate at which this angular displacement occurs within a given time. We have change in angular displacement. Jijjiirama angular displacement qabna yoo ta'e, inni kun reeshoo inni reetii inni yeroo murtaa'e tokko keessatti ittiin deemu, reeshoo inni yeroo murtaa'e tokko keessatti ittiin deemu angular velocity jenna jechuudha. Linear velocity irratti fakkeenyaa fi sochii dimensionii tokko yookaan immoo motion in straight line irratti ariitiin qaxxaamura adeemamee yeroo itti fudhatee firuun argama yoo ta'e, as keessatti rotational motion keessatti immoo angular velocity qaxxaamura angular velocity deemamee yeroo itti fudhatee firu jechuudha. This is angular displacement, this is displacement, normal displacement or linear. This is angular. So this is the rate of angular displacement given within a time change. That means what? Angular velocity is measured by change the displacement with given time. This different rotation rate can be quantified by average velocity VAV. That means yeroo sochiin jijjiirama uumamu yookaan immoo jijjiiramni gidduu isaatti uumamu average fudhanna jechuudha. Kanaafuu average angular velocity is what? The ratio of angular displacement of the motion to time interval during which displacement occurs. So how we can calculate the average angular velocity? We can use this formula. We know that average linear velocity is equals to displacement at final distance minus displacement at initial distance over time at final minus time at initial. From the rotation motion, change in angular velocity, average angular velocity means change in angular displacement with change in time. This means this angular velocity becomes what? Angular displacement as the final and angular displacement of the initial motion over time at final motion minus time at initial motion. This is what? Average angular velocity. So the unit of angular velocity is rad per second. Rad per second is what? The unit of displacement is radians, per unit of time is second. So the angular velocity is measured by radian per second. The next term, important term used in rotational motion is what? Angular acceleration. Angular acceleration is analogous to acceleration normally. Acceleration which is used in linear motion. So it is the rate of angular velocity within time. We know that acceleration in the linear motion, acceleration or a motion in a straight line can be defined as the rate of change of velocity within given time. Inni kun guulli kan sochii daandii sirrii yookaan sochii daandii qajeelaa irratti taasifamu jijjiirama ariitii yeroo yuunitii tokko keessatti taasifamee jenneerra. As keessatti rotational motion keessatti immoo angular acceleration analogous isa kanaati. Yookaan immoo isa kana wajjin wal fakkaataa innis change in angular velocity within time. If the angular speed of the object changes from initial to final, then the time interval change of t, the object has angular acceleration. This means what? This angular acceleration becomes change in angular velocity within change in time. So the average angular acceleration can be measured by rotating rigged object defined as what? The ratio of change of angular speed to time interval. This means what? Angular acceleration becomes average angular acceleration becomes final angular velocity minus initial angular velocity over time final motion time initial. This is what? Average angular acceleration, which is analogous to linear acceleration. So angular acceleration has the unit of rad per second square. Here, this is the unit, rad per second square. We know that the unit of linear acceleration is meter per second square. Analogously, the unit of angular acceleration can be measured by rad per square. So the next issue is how we can determine the direction of angular velocity and angular acceleration. We can determine the angular velocity and angular acceleration, their direction. How we can determine? Let we see. Angular velocity and angular acceleration can be treated as vectors. So two of them are vectors. Lamaan isaaniiyyuu akka vector quantity ilaalla. Kanaafuu yeroo ibsinu vector quantity taanaan immoo qaamolee kalqabeedha yookaan qaamolee safaramoo kalqabee ta'an jennaan yeroo ibsinu hammaa fi kallattiitiin ibsuu qabna jechuudha. Must be expressed or described by using magnitude and direction. Then, to determine the direction, we have to use right hand rule, which states that yeroo kallattii isaanii himuu barbaannu yookaan kallattii isaanii ibsuu barbaannu, magnitude isaanii bifa armaan oliitiin shallagnee argannee kallattii isaanii immoo ibsuu yoo barbaanne seera harka mirgaatti fayyadamna jechuudha. Seerri harka mirgaa kun maal jedhaa? When the four fingers of the right hand are wrapped in the direction of rotation, quboonni keenya arfan gaafa harka mirgaatiin wanta sana sochii sana ibsinu quboonni keenya arfanii kallattiitti wanti sun rotate ta'u yoo nutti argisiisanii, qubni keenya abguddoonni gubbaan immoo kallattii maaliin nu agarsiisa jechuudha? Kallattii angular velocity nu agarsiisa. Angular velocity nu agarsiisa jechuudha. Erga kallattii angular velocity barree booda, the direction of angular acceleration is defined as the same as angular velocity. Kallattichi the same dha. Eenyu faana jechuudha? Angular velocity faana the same ta'a jechuudha. Angular direction angular acceleration keenya. Kanaafuu if the angular speed or angular velocity is increasing in time, if the speed is increasing, the angular acceleration is the same direction. That means what? Yeroo direction isa kana yookaan immoo hammi angular velocity keenya gaafa dabalu, angular acceleration keenya angular speed kallattii isaa faana wal qixa jechuudha yookaan wal fakkaataa ta'a. Yeroon hir'atu garuu it is anti-parallel, opposite ta'a jechuudha. Mee fakkii armaan gadiirraa sirriitti hubannu. Armaan gadiirraa hubannu. Fakkeenyaaf kan deemaa jiranii akka kanatti kan naanna'aa jiru akka kanaatti. Akkanaa naanna'aa jira jechuudha sochiin kun. Yeroo kana quboonni keenya arfan kun clockwise rotationidha jechuudha kuni. Yeroo sana abgudduun keenya inni guddaan kuni kallattii maalii argisiisaa jira jechuudha? Kallattii angular velocity argisiisaa jechuudha. Kallattii angular velocity agarsiisaa jira jechuudha. So yeroo angular velocity keenya dabalu yookaan immoo yeroo kallattiin hammi angular velocity keenya dabalu, angular acceleration keenya asii olee ta'a. Egalee sochichi tokkumadha. Yeroo angular velocity keenya hammi isaa hir'atu immoo angular acceleration keenya maal ta'a jechuudha? Anti-parallel ta'a. Anti-parallel ta'a. Kanaafuu angular acceleration fi angular velocity kallattiin isaanii walirratti kan hundaa'edha jechuudha. So inni itti aanu equation of motion for uniform angular acceleration. Equation of motion for uniform angular acceleration. Yeroo darbee jalqaba boqonnaa kanaa irratti 5 equation of motion with constant acceleration jennee ilaallee turre. Equationiiwwan shanan constant acceleration, uniformly accelerated motion warra jennu jechuudha. Uniformly accelerated motion sana tokko jennee, lama jennee, sadii jennee equationii sana ilaallee turre jechuudha. Galtee nuu ta'a jennee. Amma immoo bifa rootationiitti gaafa deebinu yoo motioniin keenya bifa rootationii ta'e immoo equationiin sun akkamiin rootationii keessatti hojiirra ooluu akka isaan danda'an ilaalla jechuudha tokko tokko. So the set of a set of kinematic equation exists for rotational motion is just as they do for transitional motion. Transitional motion keessatti isa jalqaba irratti ilaalledha. Yoo yaadattu ta'e gaafa boqonnaa kana eegalle nu fayyada jennee ilaallee turre jechuudha. So they have similar form as derived in similar fashion. So let we see derivation one by one. Derivation isaanii ilaalla jechuudha. Equationii shanan sun keessaati inni tokko inni transitionii keessatti yookaan immoo sochii dimensionii tokko keessatti inni nuti beeknu tokko V finaliin V initially ida'uu acceleration times time jenneera. This is first equation in transitional motion. Then how we can find in rotational motion? We know that angular acceleration is given as final velocity, angular final velocity minus angular initial velocity over time, where this is what? Final angular velocity. And here, this is what? Initial angular velocity. and t is what? Time. Or we can say change in t. Change in t jennee fayyadamuu dandeenya. Rakkina hin qabu. So kanaaf asirratti maal arganna jechuudha? Yoo equationii kana criss cross goone angular acceleration times time is equals to final angular velocity minus initial angular velocity. Initial angular velocity. Kana qaba. Rearranging this equation, we get final angular velocity is equals to initial angular velocity plus acceleration times change in t or t, no problem. So this is first equation of what? Equation 1 for angular motion. Angular motion. This is the first equation for uniform angular acceleration. Uniform angular acceleration. So this is what? The first equation. The next one, if angular acceleration is constant, average angular velocity can be obtained. If angular acceleration is constant, average angular velocity can be obtained. It can be obtained, or we can calculate the average angular velocity. For example, the average angular velocity can be measured initial angular velocity plus final angular velocity over 2. Since angular acceleration is what? Constant. We know that average angular velocity can be given as change in angular displacement with change in time. Then substitute this equation into this one. Then we get initial angular velocity plus final angular velocity over 2 is equals to change in angular displacement over change in time. By making crisscross this expression, we get change in angular displacement becomes 1 over 2 initial angular velocity plus final angular velocity times change in time. This is what? The second equation. The second equation of constant angular acceleration. So, second equation is change in angular displacement is equals to 1 over 2 initial angular velocity times change in t, which is analogous to the linear, which is given by s is equals to 1 over 2 v final plus v initial times time. V final times v initial times time. So this is what? The second equation for constant angular acceleration. What's the third equation? How we can find the third equation? We know that we have the first equation, we have final angular velocity is equals to initial angular velocity plus angular acceleration times change of t. Then the second equation, we have change in theta or angular displacement is given as 1 over 2 initial angular velocity plus final angular velocity times change in t. Kana lamaan qabna jechuudha aga yoonaatti. Kanaaf amma gaa maal goona? Let we have final velocity is equals to initial velocity plus acceleration times change of t. Then substitute this into this equation. That means in place of final angular velocity, we can substitute this equation. Then we get change in angular displacement given 1 over 2 into initial angular velocity plus substitute this one. Initial angular velocity plus a change of t times change of Then we got what? Change in angular displacement is equals to 1 over 2 initial angular velocity plus acceleration change in t times t. This becomes here 2 initial angular velocity times change of t over 2 plus a change of t square over 2 because this change of t is distributed to all equation. Then change in angular displacement becomes what? Initial angular velocity times change of t plus 1 over 2 angular acceleration times change of t the whole square. This is what? Third equation. This is third equation. What about the fourth? What about the fourth equation? And derive it. From the fourth, for deriving the fourth equation, we have final angular velocity is equals to initial plus acceleration times change of t. From this one, initial angular velocity can be calculated by final angular velocity minus acceleration change of t. Then we have change in displacement equals to average angular velocity times change in time. Substitute this by this one. Then change in displacement is equals to 1 over 2 into final angular velocity minus acceleration times change of t plus final angular velocity times change of t. Here we get what? 1 over 2, here final velocity, 2 final velocity minus a change of t times change of t. This becomes 2 final angular velocity times change of t over 2 minus 1 over 2 acceleration times change of t the whole square. We get what? Change of displacement is equals to final angular velocity times change of t minus 1 over 2 angular acceleration times change of t the whole square. This is what? The fourth equation. This is the fourth equation. What's the fifth and the final equation? What is the fifth? For constant angular acceleration, the fifth equation can be derived. We have average angular velocity is equals to initial angular velocity plus final angular velocity over 2. Average angular velocity is equals to initial angular velocity times final angular velocity. Then we have change of t is equals to final velocity minus initial velocity over acceleration. From what? We have acceleration is equals to final angular velocity minus initial angular velocity over time. Kanarraati kan argannaa jechuudha. Derive gochuu dandeenya kana. Maal beekna kan biraa kan nuti beeknu change in angular displacement is equals to 1 over 2. Change in angular displacement is equals to 1 over 2 initial angular velocity plus final angular velocity over 2 times t. Initial angular velocity plus final angular velocity times t qabna jechuudha. Inni kun equationii isa lammaffaa irratti arganne sana jechuudha. Equationii isa lammaffaa irratti arganne sana jechuudha. Erga kana goone booda maal qabna asiitii taayimii kana qabna. Kanaaf maal goona change in angular displacement is equals to 1/2 initial angular velocity plus final angular velocity over 2 times final angular velocity minus initial angular velocity over a. Kan erga waliin baay'isnee booda equation shanaffaa arganna jechuudha. Waliin baay'isnaa rearrange erga goonee booda equation shanaffaa arganna jechuudha. Equation shanaffaan keenya kun maal ta'a jechuudha? Equation shanaffaan keenya final angular velocity square is equals to initial angular velocity square plus twice of average angular acceleration times change in angular displacement. This is the fifth equation. So derivation in uniform angular motion kana ta'a jechuudha. So the kinematics for rotational motion is completely analogous to what? Transitional kinematics. Suma laalle jechuudha. Kana laalleerraa equationota kana shanan transitional motion keessatti yeroo darbe laalleerra. Isa transitional motion keessatti yookaan immoo sochii dimension tokko keessatti laallee garaagarummaan isaa yoo jiraate simboolii irraa kan hafe kan biraan jiru jechuudha. So when solving problems involving rotational motion, we use variables that they are similar to linear variable. For example, distance, velocity, and acceleration. But take into account when in a rotation or in transition. When a rotation in or a transition. So before we going to solve the problems, let we see this one. We define the angle of rotation as this change of theta or angular displacement is the angular equivalence of change of s. This means what? When transition keessatti yookaan immoo sochii uniform accelerated motion keessatti immoo rotation keessatti angular velocity kun equivalence to what? The linear velocity. Equivalence wal madaala jechuun analogous equation isa jennu jechuudha. Angular acceleration kun equivalence to linear acceleration a. Erga kana goone booda how we can relate the analogous equation of linear motion and angular motion. When it is a linear motion with constant acceleration and angular motion with constant angular acceleration. So we have already seen those equations. 5 equations. V final is equals to initial velocity plus acceleration times change of t. But in case of angular, I've derived angular velocity final is equals to initial angular velocity plus acceleration times t. VAV average velocity is equals to V final plus V initial over 2. But in case of constant angular acceleration, average angular acceleration is measured this one. So those are the equation, the analogous equation between linear and angular motion. So what is the next one? The relationship between angular and transitional quantity. Especially we have two quantities which have related by their transitional quantity, the angular and the transitional quantity. When an object moves in a circle, the transitional velocity vector is always tangent to circular path, and hence it is called tangential velocity. When this object moves in a circle, here this object moves in a circle. At this point, here the object moves such like motion. In this case, at this point, there is a tangential which is tangent to the given circle. Tangential velocity. We have tangential velocity. When a circle is this one, a line which touches the point of circle at one place is called tangent line. The same is true for this velocity is tangential to the given motion or the given circular path. The given circular path. So the magnitude of tangential velocity at point P is defined as the magnitude of tangential velocity is what? Change in S or the arc length times change in T. Now that this is in relation in transitional motion, where S is distance traveled by this measured along the circular path or arc length, and we have already seen change of S equals to what? Radius times change in angular displacement. Kana laallee turre jechuudha jalqaba irratti. Yeroo barumsa keenya guyyaa irraa jalqabaa irratti laalleerra kana. Kanaafi Kana finnee yoo relate goone jalqaba irratti kan nuti argannu tangential velocity vt jechuu dandeenya. Kana tangential velocity change in arc length over change in time. But what is change in s? Change in s is what? Change in angular displacement times radius. Then substitute this equation into this one. Then vt or tangential velocity is equals to change in angular displacement times radius or change in t. What is this quantity? This quantity can be replaced by what? Angular velocity. So vt is equals to tangential velocity is equals to angular velocity times radius. So this can be concluded by what? The tangential velocity or the linear velocity of object which moves in circular paths is given by the tangential velocity of the object given in circular path can be given the product of angular velocity times radius of the given motion. Radius of the given motion. So we correlate what? The angular, we correlate also the tangential velocity of the given motion in circular path can be given as the product of angular velocity times radius of the given motion. We correlate angular acceleration of the rotating rigged object to the tangential acceleration of the point by taking the rate of change v also. For example, we have acceleration is equals to change in velocity over change in time. Then this means what? This means what? Tangential velocity is equals to velocity, angular velocity times radius. Substitute this one. Then acceleration is equals to what? Angular velocity times radius over change of t. Here, what is this quantity? This is what? Tangential acceleration is equals to angular acceleration times radius. Actually, here this is tangential acceleration because a simply we represent by a. So angular tangential acceleration is given as what? Radius times angular acceleration. Angular acceleration. Okay. So this is, let we see do examples. Examples. What is the average angular velocity and the angular acceleration of rotating wheel if its angular speed is changed from 30 rad per second to 50 rad per second in 2 seconds? Let we do this example. Try to think first. First, the given. What are the given? The given is what? Initial angular velocity is equals to 30 rad per second, and final angular velocity is equals to 50 rad per second. 50 rad per second. So the given time is equals to 2 seconds. What's the question? Average angular velocity. Average angular velocity. Average angular velocity. Angular velocity average becomes what? Initial velocity plus final velocity over 2. Then substitute this one. 30 rad per second plus 50 rad per second over 2. This becomes 80 rad per second over 2 becomes what? 40 rad per second. This is what? Average angular velocity. What is B? Angular acceleration. Angular acceleration becomes final velocity minus initial velocity over time. This means what? 50 minus 30. This is 20 rad per second over 2 seconds. This is what? 10 rad per second square. So this is the average angular velocity and the angular acceleration from the given question. The next question, question number 2. The rotating wheel has initial angular velocity of 10 rad per second. 10 rad per second. Initial angular velocity. Initial angular velocity is what? 10 rad per second. And accelerate at what? 2.5 rad per second square. This is angular acceleration. Question number 1a. How many revolutions are completed in 10 seconds? In 30 seconds. T is equals to 30 and T is equals to 30 seconds. How many revolution means how many change of theta is given in revolution? How many change of theta is given in revolution? So let we find the revolution. We have from the given equation 3. We can use equation 3. So change in angular displacement is equals to initial angular velocity times t, initial angular velocity times t plus 1 over 2 a t square. We have one revolution is equals to 2 pi rad. So change in theta is equals to, we have what? Initial angular velocity 10 times what is time? 30 plus 1 over 2. What's the relation? 2.5 times 30 square. This becomes how many? This becomes 226.9 revolution. Try to check it by using this expression. Kan nuti argannu raadiyaaniitiin arganna. Raadiyaaniitiin arganna. Kuni 300 raadiyaanii ta'a. Inni kun immoo 1125 ta'a. 1125 raadiyaanii ta'a. Erga raadiyaanii kana lama walitti daanee booda hariiroo kana fayyadamne gara revolution'itti jijjiirra jechuudha. Gara revolution'itti jijjiirra. Revolutioniitiin waan nu gaafateef gara revolutioniitti jijjiirra. Revolutioniitiin nu gaafate waan ta'eefidha. Eshi gaafiin itti aanu what is the angular speed of the wheel at t is equals to 20 seconds? Final angular speed in keenya yeroo sekondii 20 keessatti meeqa ta'a kan jedhudha. Yeroo sekondii 20 keessatti final angular speed in keenya meeqa ta'a kan jedhudha ilaallachuudha. Inni kun baay'ee salphaadha. Maal goona? Jalqaba irratti kan nuu kenname initial angular speed qabna. Initial angular speed in keenya 10dha. 10 rad per secondii qabna jechuudha. Kan inni nu gaafachaa jiru ishee kana irrattidha. Kanaaf at time of 20 second maal barbaadna jechuudha. Final angular speed in keenya maal ta'a? Initial angular speed plus acceleration times time jenna jechuudha. Inni kun 10 rad per second plus 2.5 times time meeqa irratti? 20 secondii irratti jechuudha. Kanaaf inni kun immoo maal ta'a? 60 rad per second. This is final angular velocity at this time. 20 secondii irratti final angular velocity in keenya 60 ta'a. The next one, question number 3. A car of wheel has an initial angular velocity of 6 rad per second. Maal qaba? Kaariin kun initial angular velocity isaa maalidha? 6 rad per second qaba. And constant angular acceleration 3 angular acceleration is equals to 3 rad per second square qabna jechuudha. Calculate angular velocity after 100 revolution. If change of theta is equals to 100 revolution, how many final angular velocity? How we can find it? How we can find? First, 1 revolution is equals to 2 pi rad. Then 100 revolution is equals to how many? How many rad? This is equals to 628 rad. 200 times 3.14 jechuudha kun. Kun maal keenyadha? Change in angular displacement keenyadha jechuudha. Change in angular displacement keenya 628 raadii qabna. Asirraati jechuudha kanarraa kana jijjiirra. Achi booda maal goonaa? Formula kana fayyadamna. Kan nu gaafate maalidha? Final angular velocity waan ta'eef. Final angular velocity is equals to initial angular velocity plus twice of angular acceleration times change in t jenna. Kana bakka buusnee arganna jechuudha. Initial angular velocity keenya 6 rad per second the whole square plus twice of how many acceleration we have? 3 rad per second square times 628 rad. Meeqa dhufa jechuudha? Dhumarratti 61.68 rad per second dhufa. Kun final velocity keenyadha. Square root jala galaa jechuudha. Inni kun square root jala galee hundi isaa. Kuni root jala galee kana nuuf fida jechuudha dhumarratti. So equationoota shanan duraan drive goone sana fayyadamneetu hunda isaa kan hojjechaa. Gaafiin itti aanu gaafiin arfaffaan a wheel has radius of 20 cm and accelerate from rest to this revolution per second. We have radius equals to 20 cm. This means 0.2 meter. Then we have initial angular acceleration equals to 15 revolution per second. This is what initially 0. Start from rest. Then finally 15 revolution per second. Revolution per second at time what? 30 seconds. What is the magnitude of tangential acceleration? Magnitude of tangential acceleration. How many? Tangential acceleration is given as AT. A tangential acceleration is angular acceleration times radius. Here we have formula. But what about A? Then angular acceleration is equals to final angular velocity minus initial angular velocity over time. This means what? Final angular velocity 15 revolution per second minus 0 over how many t we have? 30 seconds. 30 seconds. This becomes what? This becomes 0.5 revolution per second. This is 0.5 revolution per second. How many revolution? How many radians are there in one revolution? Let's we change this revolution into rad. So how we can convert the revolution into rad? We have already seen the relationship between the revolution and the rad. Then this becomes 1 revolution is equals to 2 pi rad. How many? 0.5 revolution. How many rad? This is what? Pi rad or 3.14 rad. So the given acceleration A is equals to angular acceleration is equals to 3.14 rad per second square. 3.14 rad per second square. But then tangential acceleration is equals to angular acceleration times radius. Multiply 3.14 rad per second square times 0.2 meter. This becomes what? This becomes how many? 0.6 meter per second is 0.6 meter per second is. What is the next equation? A car accelerates from 20 to 24 in 5 seconds. Then this is what velocity. We have V initial, transitional actual, 20 meter per second. V final is equals to 24 meter per second. Time is equals to 5 seconds. Calculate the angular acceleration of the wheels if the curve of radius is this one. Curve of radius is 0.4 meter. We can find the angular acceleration. First, we have to find the linear acceleration. Tangential acceleration is equals to V final minus V initial over time. This becomes 24 meter per second minus 20 meter per second over how many time? 5 seconds. This becomes what? This becomes 0.8 meter per second square. Here, this is tangential acceleration. We have tangential acceleration is equals to angular acceleration times radius. Angular acceleration angular acceleration is equals to tangential acceleration over the given radius. What's tangential? 0.8 meter per second square over how many radius we have? 0.4 meter. This becomes 2 rad per second. This is angular acceleration, which is calculated by using this formula, depending on linear acceleration. The next one is the angular velocity of a bicycle wheel is 18 rad per second. 18 rad per second. Okay, angular velocity of the bicycle. The angular velocity of the bicycle. Here we have angular velocity of the bicycle is 18 rad per second. The angular velocity is rad per second. If the radius of wheel is equals to 40 centimeter, means 0.4 meter. What is the speed of bicycle in meter per second? The linear speed of the bicycle or the tangential speed is equals to angular speed times radius. So this becomes what? What's angular speed? 18 rad per second times 0.4 meter. This becomes what? 7.2 meter per second. So this is a direct relationship. Tangential velocity given by angular velocity times radius general. So kuni video keenya kan paartii lammaffaa boqonnaa lammaffaa rotational motion yommuu ta'u, video keenya saxaanu paartii sadaffaa irratti rotational dynamics jedhu qabannee isiniif dhiyaanna. Hangasitti nagaan nu tura isiniin jenna. Galatoomaa waan nu eeggattaniif ulfaadhaa. YouTube keenya like, share, subscribe gochuu hin dagatinaa isiniin jenna. Ulfaadhaa kabajamaa baay'ee isin jaallannaa nu jiraadha.